Okay, so my problem states that Johnson and Betsy Waring have a jar containing 80 coins, all of which are either quarters or nickels. The total value of the coins is $14.60. How many of each type coin do they have? So we're trying to determine how many quarters they have and how many nickels they have. I'm going to let Q be the number of quarters, and I'm going to let N be the number of nickels. I could have used X and Y, but Q and N will help me out down the road, knowing what means what. Alright, so I should be able to set up two equations from this word problem, given that I need a system. The first equation is going to come from the fact that the jar contains 80 coins. So that means if I add the number of quarters to the number of nickels, I will get 80 coins. So there's my first equation. Not too bad. My second equation will come from the sentence that says the total value of the coins is $14.60. This equation requires a little more thinking. So I'm thinking about the value of the coins. A quarter's worth 25 cents. So the quarter is going to be assigned a 0.25 Q plus, thinking of what a nickel's worth in terms of value, that's 5 cents. 0.05 N, and that will equal, if I add those two values together, the problem says that equals a total value of $14.60. Okay, so here are my two equations that I derived from this word problem. Take a second and make sure it makes sense to you before moving on. Now I'm going to move on and solve this system of equations. The first thing that might be helpful is to multiply the bottom equation by 100 so that you don't have to deal with the decimals. Okay, so if I multiply the bottom equation by 100, I'll get 25Q plus 5N equals 1,460. And I think that'll be a little more helpful, so we can strike through this equation here and focus on solving the system of equations that I have left. Okay, so to solve that system, I could do the substitution or the elimination method. Notice everything's lined up, so this is setting up again better for the elimination or the addition method. And I'm going to change it up, and I'm going to try to eliminate my n's. So I'm going to do that by multiplying the top equation by -5 and the bottom equation by +1. And again, my goal is to have the n's eliminate. So let's distribute -5 times the top equation. That would give me -5Q minus 5N equals -5 times 80 is -400. Okay, multiplying the second equation by 1 will not change it, so it'll still be 25Q plus 5N equals 1,460. Okay, so I notice my n's are going to eliminate as I wanted. So we'll go ahead and add these two equations. -5Q plus 25Q is 20Q. -5N plus 5N will eliminate, as we talked about. -400 plus 1,460 is 1,060. I'm going to now divide both sides by 20. That's going to tell me that Q equals 1,060 divided by 20, which is 53. So apparently there are 53 quarters in the jar. Alright, so now all I have left to determine is how many nickels are in the jar. I can go back to one of my two original equations. I'm going to go back to the easiest of the two original equations, which said that Q plus N was 80. The total number of coins was 80. I know that there's 53 quarters, so I'll substitute 53 in for the quarters. Subtract 53 from both sides to get N by itself. And N is going to equal 80 minus 53, or 27. So I have determined that in this jar of Johnson and Betsy Waring, there are 53 quarters and 27 nickels. To check myself to know that I'm right, 53 plus 27, if I add those two together, that gives me 80 total coins. If I think about value, 53 quarters, how much money would that be? 27 nickels, how much money would that be? And hopefully if I add that up, I should get $14.60. Think about that for a second, and it should make sense. Hope this helps.